Hello, welcome back to my channel. In this video, we'll derive a relation between capital R and small r, where capital R is the radius of atom in close packing and small r is the radius of the octahedral void. Let us derive the relation between capital R and small r. If the radius of the octahedral void is small r and radius of the atom in close packing is capital R, derive a relation between capital R and small r.
Suppose there are 4 atoms and above it an atom can be kept or lattice point can be kept, below another atom or lattice point can be kept. So this part in the middle is the octahedral void. This is the octahedral void. Let the radius of this octahedral void is smaller, radius of lattice point capital R, this is R, this is R, this is R, this is smaller, this is smaller, and this is a right angle triangle. This part becomes 2R and this part becomes R plus R. R is the radius of octahedral void, R is the radius of lattice point. Then you see 2R square is equal to R plus R square plus R plus R square. Suppose this is A, this is B, and this point is C. So BA square is equal to BC square plus CA square. Then four R square is equal to 2 into R plus R square. Cancel 4. So 2R square is equal to R plus R square, or R square is equal to R plus R square by 2, or R is equal to R plus R by root 2, or you can say root 2R is equal to R plus R. Root 2R minus R is equal to R. Root 2R means R is common. So root 2 minus 1 is equal to R. R, this is 1.414 minus 1 is equal to R. This part becomes 414. R is equal to R. Obviously, this is the radius of the octahedral void and this is the radius of the lattice point. So lattice point is bigger. So 0.414 times of the radius of lattice point is equal to the octahedral hole.
Let us derive the relation between capital R and small r. Thank you for watching the video till the end. Thank you once again for your support and care. Thank you for your comments. Thank you for your inspiration. Stay safe. Take care of your health. Bye-bye.